This is problem number 37 from chapter 5, and in it we have a sphere of mass 3.0 times 10 to the negative fourth kilograms. It's suspended from a cord. A steady horizontal breeze pushes the sphere so that the cord makes a constant angle of 37 degrees with the vertical. We want to find the push magnitude and the tension in the cord. So I've already drawn a picture here. Here's our sphere. I've drawn the vertical line. So we know that when it says a constant angle of 37 degrees with the vertical, from that vertical line, we have our 37 degrees right here. We have a gentle breeze. I've drawn my breeze. It's not a force, it's just a breeze. But I've drawn my force from the breeze right here. I call that F wind. I could have also drawn it on this side of my sphere, but since my arrow is pointing to the right, I prefer to draw it over on this side of it. And then, of course, my force going down is my weight, which is also my force due to gravity, which is also mass times gravity. So I wrote down what I know. I know that since it's not moving at all, then the sum of my forces both in the x direction and in the y direction will equal 0. So I've written that down right here. I've written down my mass. And then what I'm doing right here is I'm drawing a free body diagram with the components of my tension, because when I'm dealing with the forces in the x or the y, I don't want a diagonal force. Instead, I just want forces in the exact x or y directions. And so now I will simplify this a little bit more. Since I know that this is 37 degrees right here, if I'm solving for the tension in the x direction, then I would have to use sine with my 37 degrees to figure out that tension. So Tx equals T sine 37, whereas Ty would be using cos. T cosine 37. And so always be careful about that. Always note what your picture looks like, because I know that often we like to associate y with sine, but that's just not the case in this particular situation. And so let me solve for our weight, since we actually can solve for that. So our weight equals our mass times gravity, which equals 3 times 10 to the negative fourth times 9.8. And that will equal 0.00294 newtons. And so what that tells me, since I know that I'm in equilibrium, the sum of the forces in the y direction equals 0. So sum of the forces in the y equals 0. So I will have Ty minus weight equals 0. And we can see that Ty will equal our weight. So Ty equals 0.00294 newtons. Now, the good news about this is that we know that Ty equals T cosine 37. So I can say that this number equals T, being the full tension, cosine 37. And so I can use my calculator. This number divided by cosine 37 will give me my tension, which happens to be 3.68 times 10 to the negative 3 newtons. And so I've solved for part B, and now I can solve for part A. So the push magnitude, again, the sum of these forces is also 0, because similar to this situation right here, I have the sum of the forces in the x would be F wind minus Tx equals 0. Therefore, F wind equals Tx. And so if I solve for this, I know that Tx is T sine 37, but good news for us, we already know what our tension is, so I can just plug that in there, and I will find out that the force from our wind is 2.22 times 10 to the negative 3 newtons. And so the really important thing to note from here is that when you have a situation like this, break your forces into components, recognize that the sum of the forces equals 0, and then work through everything you know to find the things that you don't know.